recording. Okay, so we're at 5 minutes, meeting officially started. So first about BIM, business event analysis and modeling. And the idea is very simple. You talk to the client to extract information from them about their business events with the goal to make your star schema your data warehouse, right? So you interview business stakeholders, you document the data and the process they follow, and you create something which is called event matrix or fact matrix. And you see it on the right, kind of the template, how things are done. So you have facts and dimensions. I mean, it's too small here to analyze, but it's not difficult. And in our area for data architecture, we actually have a folder with all the templates in Excel format, which you can use. So there are some images. So it's not rocket science. You just ask them questions like when, how and who, how many, where, why, and what, and kind of to fill this matrix with some content. So here's a little bit specific example. Like here, for example, you have orders, and these are examples of orders. So who is the name of the person, what product was bought, when, like what date, and so on. So this is illustration to this matrix, how it's filled. So here you have product, here you have orders. Okay, so BIM is abbreviation for business event analysis and modeling, right? So you have business events, which are facts, which are orders, for example. Let's say it's orders on Amazon. And analysis of those business events and modeling it, meaning creating a database schema. And the process is agile. That means that you talk to clients over and over again, and in increments, you create and refine the model, right? So agile methodologies focus on delivering an end-to-end minimum value product by iterative cycles as opposed to fully built solution in one shot, right? And when you talk to a client, you concentrate on three things. So first, you want to build your star schema for your reporting, for your data warehouse. You want to figure out the ETL process to populate it. And also on the other side, the BI tool, how it will be accessing your data, right? So all three things. Just a reminder, like the star schema. So you have fact table in the middle, you have dimensions around it. And BIM helps you to figure out this fact and dimensions. I was doing stuff like that many times in my life. I never used the BIM methodology explicitly, but I kind of used the underlying spirit, like what you're trying to accomplish. It's a good idea to use it because as you do it, you create documentation, and apparently it improves your relationship with your business stakeholders, with your clients. They understand what you're after, and you have documentation which you then can put as part of your deliverable. So it's a good idea to use these templates. So these are kind of questions you may be asking: who, how, what, and so on. This is again example of your customer, product, order, whatever. And again, example. So you see, it's the same thing over and over. It's not rocket science. This is kind of a reference card or cheat sheet in two places, which gives you some common abbreviations, what kind of events may be, what dimension types, and so on. There is a book about BIM, which you can buy and read. There are tutorials on YouTube. There are seminars, which cost money. But it's really, you can learn it yourself and just follow the templates. Here are some links, including the book and templates to follow. So I guess this is it for the first PowerPoint about BIM. And now we are after the second, about 3 clouds. So there are many clouds. So this picture is June 2020. So it's a year old. And you see Amazon, of course, is the leader. Azure is also pretty big, and Google, and then everybody else is much smaller. So I will concentrate on Amazon, Azure, and Google, right? So here we have Amazon, AWS, Amazon Web Services, and they have a marketplace. And it's really very similar to a regular Amazon website. So this is the marketplace, and you see if they have more than 10,000 results, right? And a lot of vendors. You see, show all 2,600 vendors who's selling stuff. So let's try something like SQL database, just out of curiosity. Okay, we have almost 600 results. So you have a choice.
Hey, Lev.
Yo.
Let's see. Are you like we're still seeing your PowerPoint slide? Are you intending to switch over to the browser?
Oh gosh. Yeah, because I'm sharing only the PowerPoint. But anyway, sorry. Then I will not show it. Thank you. But the idea is that on this marketplace, there is a lot of different services and a lot of different vendors. Microsoft, which you mostly are very familiar with, it's mostly all about Microsoft, although they also have third-party products, right? So PostgreSQL or MySQL or whatever you need, they usually have it. And Google Cloud, again, mostly about Google services, but they do have a lot of third-party solutions as well. For example, you can use Kubernetes on any one of those three. Okay, so these are the three clouds. These are just some pictures I found, and let's see. For example, servers, virtual computers, right? On AWS, they called Elastic Cloud Compute, or ECC, which usually abbreviated as EC2, like two C's, right? On Azure, it's virtual machine. On Google, it's called Google Compute Engine. Absolutely the same thing, no difference. You want a Linux server with so much memory, so many CPU cores and hard drive, so you can have it. Serverless computing. Well, on Amazon it's called Lambda, on Azure it's called Azure Functions, on Google it's called Cloud Functions. Very similar. Kubernetes management exists on all three. Storage. Well, simple storage service, or S3, right? This is a famous S3 buckets on Amazon. Azure Blob Storage or Blob Buckets on Azure, and cloud storage on Google, right? File storage, again, Elastic File Storage on Amazon, Azure Files, file shares on Azure, and File Store on Google. You see, names are different, but it's the same functionality. Block storage, meaning this is a disk which you can mount on your computer. So for example, on Amazon, it's called Elastic Block Storage, or EBS. I use those. This is just a managed disk. You select how big it is, let's say 4 terabytes, and you mount it on your virtual machine. Here it's called Azure Disk or Managed Disk on Azure, and Persistent Disk on Google, right? Relational database. Oh gosh, don't have started, because like RDS, relational database service, but there are so many options for databases on Amazon Cloud. Azure also has a lot of third-party solution, but mostly they promote their own servers, which are very good, so rightfully so. And here they have Cloud SQL. Cloud SQL at Google, it's actually a combination. It may be MySQL, PostgreSQL, whatever. It's like RDS. You can choose. NoSQL databases. Okay, DynamoDB, which is a key value store, or mostly JSON text, like as an information which is being stored. So key and value is JSON. Key is maybe a string or something, and value is JSON usually. Cosmos DB in Azure, absolutely the same thing as DynamoDB, very similar. Firestore in Google, I never worked with it. I presume it's also very similar. And then you have virtual network, you have content delivery systems, you have DNS servers and authentication. You see here you have Active Directory on Azure, very familiar. and we have key management, network security. So all the key components are absolutely the same, just named a little bit differently. This is another slide, again, showing side by side some of those things. This is another slide, again, more entries, but just shows how similar they are. I want to go in a little bit detail. Oh gosh, why it doesn't show correctly? I don't know what is happening. Okay, so virtual machines. I already told that, well, they have different icons apparently. Okay, this is also screwed. But anyway, so it's a EC2 on Amazon. I worked with those, and EBS is a disk, right? On Azure, it's a virtual machine and managed disk. And on Google, it's Google Compute and persistent disk. Okay, but it's the same thing. S3, simple storage. Well, we're mostly on Azure familiar with data lake storage, Azure blobs, Azure files, and on Google it's called cloud storage. Same thing. Databases, well, huge variety. You can, for example, on Amazon, you have a choice of multiple relational databases. Redshift is the old like PostgreSQL compatible. Snowflake, it's a third party, very popular now for data warehouse. Athena, which is kind of serverless. Well, it is basically managed Apache Presto DB. So it's an open source project, but Athena implementation on the cloud. Interesting, because this is a big database. I believe it's also global, like DynamoDB, which is a key value store, and they have Neptune, which is a graph database, also global. In Azure, we don't have selection like that. The only global database on Azure is Cosmos DB, which is like DynamoDB, but there is nothing similar to Athena or Neptune, as far as I know. But of course, Azure strength is Microsoft SQL Server and data warehouse. On Google, you have huge variety of databases. And most important, of course, is BigQuery. So BigQuery is global. BigQuery is SQL compatible. BigQuery can handle huge amount of data, and it's cost effective. And it's actually under the hood. It's not a monolithic thing. It uses different types of storage, files or tables. It's very interesting architecture and a tool. So yeah, it's a serverless data warehouse, globally scalable, cost effective, right? Okay, so I will not go into all these different things. And by the way, all of them, of course, well, not BigQuery, but similar, available on AWS, which is a huge number of databases. Okay, go next, integration solutions. Well, we know Azure, we have Azure Data Factory or Synapse Integrate, which is basically the same thing. You create pipelines, and similar tools available on Amazon. Well, you see the list of some of them, and on Google. I didn't actually work with any of them, but I presume that they're very similar to what we have on Azure. Serverless functions. This is interesting. I worked a little bit with functions, and they make sense for certain types of applications. When you need to load data in big pieces, like you load in data warehouse, you usually don't need functions. But when you need to send data in small pieces, then they make sense, right? And I'm a Python person, so I like to work with Python. But Python probably is not the best language, because in all three clouds, if you want to process data in Python, so let's say you receive a small JSON file or CSV file, and you want to use Python to process it, and you want to use pandas, when this function starts on some server, this server doesn't have pandas. So you have to install it. You have to run pip install. I don't know why pandas still not a default option on like standard Linux server. So in all three clouds, you need to before, like making the pip install installation as a part of starting the function. Which is not good because it slows down the start. The way those functions work is that you say, well, I want to keep 10 functions in memory all the time, ready to work. And then you say how you want to scale, the rules for scaling. So you can adjust it so that there will not be initial delay mostly. But still, like from all these languages, I actually like the idea to use Go language, because Go was developed at Google and to be very fast. And also it's compiled in a very small executable, which contains all its pieces. So it doesn't require external modules. Once you have the executable, you just run it. So we have it on Amazon Cloud, we have it on Google Cloud, of course, because Go was created at Google. Unfortunately, we still don't have it on Azure. So there is no Go. Mostly people, in fact, use JavaScript. On Azure, we have JavaScript and we have TypeScript, which is about the same. PowerShell here, no PowerShell at Google. C# is everywhere, .NET, and Java is everywhere. But I don't know why today you would use Java. Interesting. So these are functions. So this is for distributed serverless, well, let's say ETL. So you get some data from one place, you process it and load it into some system, and you do it asynchronously in parallel massively. So this is serverless functions. Hadoop, Spark solutions available on all three clouds. Well, called a little bit differently, like EMR is Elastic MapReduce on Amazon, but whatever, same thing. Dashboard solutions, again, exist on all three clouds, a little bit different. Of course, we really like Power BI, but, well, other solutions are also capable. Machine learning solutions. On Amazon, it's a famous SageMaker. And what SageMaker is, they just take Jupyter notebooks or Jupyter Lab, and they call it SageMaker or SageMaker Studio. Studio is a Jupyter Lab. It's the same thing. Your main language is Python. You can run models, you can do deployments. It works same as on Azure Machine Learning Studio, and I presume same as on Google Cloud. And every time when you deploy, like when you run it in some sort of pipeline, it has to start, and it has to start the VM, it has to install all the modules you need. They're very similar. They're very similar. So on Azure Studio, we can use machine learning studio. I mean, Azure Cloud. We can do machine learning in Power BI, which is like growing and become more and more popular. And we can do machine learning in PySpark. Well, if you need PySpark, because usually this is more expensive solution, right? If you have a lot of data, then maybe it's good for you. And Google, of course, is famous for its machine learning. It has a lot of stuff. Colab is very, very famous because it's a free playground. Many people use it. So you get Jupyter Notebook with GPU for free. And many people learn machine learning on this platform, and then they transition to commercial, like paid solutions. And of course, Kaggle, again, it's a free, it's a playground for competitive machine learning. Like it's a great thing. And again, it belongs to Google. They bought it for, I don't remember, like several $1 billion several years ago. Okay. Machine learning and AI solutions, meaning cognitive solutions. On Azure, we have the services related to vision, speech, language, knowledge, search. On Amazon, we have similar things. They like to give special names for each service. Like you have QuickSight, you have Transcribe for speech to text, Poly for text to speech, translate, and so on. Extract text and data from documents, Forecast, Lex, chatbots. Yeah, so very similar. And then, of course, Google Cloud. I just put the main like categories because there is a lot. Google has a lot of AI services, very good ones. So all three provide, I don't know like the difference in prices. I don't know which one to choose. Next is data governance and lineage. And again, all three platforms have something. On Amazon Cloud, these are all third-party solutions. On Azure, we have preview coming. It's now still in preview, but it's a lot of interest for it. And by the way, preview can scan and catalog data across multiple clouds and also on-prem installations. So it's very interesting. And on Google, they have cloud governance and they have BigQuery governance. Again, BigQuery is the main tool. Like when you have big data, it's usually BigQuery. And so that's why they have a special system for it. Okay, DevOps, continuous development, continuous integration. Again, there are tools on all three clouds, quite developed. Oh, so it's kind of difficult to know all of this for all three clouds because the devil is in details, right? And the last thing I wanted to show is this use case, which I started to talk about at the very beginning. So I spoke to a friend of mine who works at this company, and they receive close to terabyte of compressed data daily. They have more than 2 petabytes of storage. They store data in BigQuery, in Google BigQuery. And when they load this data every day, it's a kind of heavy, complex, it's not just to load the data, they have to process this data. They have to select the columns, rename the columns, clean the data, split it. They need to do sharding and they need to do clustering. So they process data several times before it is ready for actual queries. A quite evolved process. And you see, they don't use a standard data warehouse. They don't use star schema. They don't like. I was talking to him a couple of years ago about data warehouse in like Azure, and they tried, and they said no, the price is prohibitive. Like the cheapest they found, which can do the load they need, is this on Google. Okay, so this is the end of presentation. I will try to stop the recording. Stop.